In this video, I'll show you how to train multiple Flux LoRAs simultaneously on an H100 GPU for free. I'll also walk you through how to generate captions automatically and structure them exactly the way you want, how to resume training a LoRA if the initial results aren't satisfactory. Plus, I'll dive into the best practices for creating captions and explain key configuration settings for training. I'll demonstrate by training a style and an object as examples. Here are the images used for training the style, along with some of the resulting images. And here are the images and captions used for training the object, along with a few of the generated results. First, let me give you a quick overview of the custom script optimized specifically for installing and training LoRAs on Modal. You can access it through this repository. This is a repository I forked from the AI Toolkit repo. The reason I created this repo is that I previously tried using the original AI Toolkit repo for training LoRA on Modal, but encountered some issues during the process. I fixed those issues, and additionally, I wanted to simplify the setup, so I wrote a simple script to make it easier to use. I also wrote an additional script to automate downloading the Flux model from Hugging Face. The original script downloads the entire Flux dev folder every time the training process is executed, which is quite large, over 53 gigabytes. I didn't want that. Instead, I wanted to download the model only during the first run and skip this step in subsequent runs. This approach saves both runtime and GPU usage on Modal. Okay, now we will proceed with the installation steps. First, register an account at Modal and Hugging Face. Just use email to register. No credit card is required. After registering, Modal will give us $30 for free per month. Yes, you are not mistaken. Modal is free $30 every month, meaning if you use up all $30, the next month you will refresh and have $30 again. And Hugging Face is for us to accept the license of Flux model and then create a token to download Flux model. After registering and confirming your email, you can search with the keyword Flux to go to the Flux model page and accept the license of the Flux model. If you don't have Git and Python installed, then you can install it or let the script install it automatically. Next, we'll download the setup script for Modal training and run it with admin privileges. Let me briefly explain what this script does. It checks if it's being run with admin privileges, downloads and installs Git and Python if they aren't already installed, clones the AI Toolkit repo to the C drive and installs the required dependencies, validates the Modal token, verifies the training config file, and ensures the .env file containing the Hugging Face token is present. Finally, executes the training command. Let's run it. The script will clone the repo to the C drive and install the necessary packages. This only happens during the first run. Next, I'll create a token on the Modal website. To do this, go to Settings and select API Tokens. Click New Token to generate a new token. Copy the token, then right-click or press Shift+Insert to paste it into the command prompt window. Press Enter, then Modal will verifying token. Next, we'll need to adjust the training parameters in the config file, create a Hugging Face token, and prepare the training data. In the repo, I've included a sample config file. You can open it with the built-in Notepad on Windows or any editor you prefer. I'll be using Notepad++. Let me explain a few key parameters. Name. This is the name of the folder that will contain the training output. In this video, I'll test training a style LoRA and an object LoRA. I've prepared two image datasets, one for training the style and one for training the object. For the style, I used images from the Alva Skog style. I came across this style through a Reddit comment. My goal with this style is purely for testing. Based on some guides on preparing datasets for training, I selected a subset of these images for the training data. Additionally, for style training, captions are not strictly necessary. After downloading the images, I simply renamed the files. This dataset contains images of varying sizes, which I left as is without cropping or resizing, since AI Toolkit has a built-in bucket mechanism to handle this automatically. For detailed instructions on preparing training datasets for different LoRA types, style, object, or character, you can refer to a guide I'll link in the comments section. The guide is thorough and easy to follow. For the object dataset, specifically the basket in this case, I created captions for each image. The requirement is that the image file name and its corresponding caption must match, differing only in file extension. Later in this video, I'll demonstrate how to quickly automate caption generation. For now, I'll start with training the style LoRA. To make it easier to manage, I named the folder containing the images with details like the trigger word, whether it includes captions, and the version. Then, copy this folder into the AI Toolkit directory and set the name parameter in the config file to match the folder name. This is just for convenience. Training folder, leave this as is, as it needs to match the mount dir value in the runmodal.py file. Trigger word, if you're using a trigger word, enter it here. In this example, I am using 1. Linear, this specifies the number of layers. Typically, you can use 8 to 16 layers. More layers allow the model to learn more complex features, but may lead to overfitting if the dataset is small. Linear alpha. This sets the alpha layer count, usually equal to or less than the number of layers. For example, if you're using 16 layers, the alpha value can be 8 or 16. I'll leave these parameters as default. Save every. This defines how often the LoRA Save Tensors file will be saved during training. Max step saves to keep, set to 4, meaning it will keep the 4 most recent Save Tensors files. Folder path. Path to the folder containing the training images. Batch size. Number of images processed per step. I'll leave it as is. A larger batch size requires a stronger GPU. Since we're using the H100 GPU, you can consider increasing the batch size to 2 or 4, but avoid setting it too high. You can adjust the GPU usage in this section of the code. Steps. This is total number of training steps. Usually, this is between 1,000 and 4,000 steps. The relationship between steps, the number of images, batch size, and epochs, as in this animation. Gradient accumulation steps. This technique simulates a large batch size on GPUs with limited VRAM by dividing the large batch into smaller mini batches and accumulating gradients. For example, suppose you want a batch size of 8, but the GPU can only handle a batch size of 2. You can configure batch size set to 2 gradient accumulation steps set to 4, because 2 times 4 is 8. EMA, exponential moving average. This technique smooths the training process by taking a weighted average of the model's parameters. It helps stabilize the model and reduces noise during training. I'll leave it as default. Name or path is path to the folder containing the Flux model. Leave this as is. Quantization, a technique to reduce parameter precision, saving memory and speeding up computation. I won't use it in this case. Sample every, set to 250, meaning a sample image will be generated every 250 training steps. Prompts, sample prompts for generating images during training. These allow you to monitor the quality of the LoRA and determine at which step the training converges. I'll test generating sample images during training using these three prompts. These prompts were created with Google Gemini based on the input images and then turned into prompts. You can use any prompts you like. For the other parameters, such as seed, guidance scale, and sample steps, I'll leave them as default. In summary, the only parameters I'll change are name, trigger word, folder path, steps, and prompts. After making the changes, click Save. With that, I've finished preparing the config file and dataset. Next, I'll go to Hugging Face to create a token. Name the token and set its permissions. Since I might want to add a step to automatically upload the LoRa to Hugging Face later, I'll select Write Permission, copy the generated token, open the .env file, paste the token inside, and save it. Now everything is ready. To proceed, simply press Enter in the command prompt window. During the first run, the Flux model will be downloaded. In subsequent runs, this step will be skipped. You can also view the logs for this process on Modal. Typically, downloading the Flux model from Hugging Face is very fast. The total size of all the necessary models for training is 53.9 gigabytes, and it usually takes only 2 to 3 minutes thanks to the Hugging Face Hub transfer feature. Occasionally, after downloading the model, the script doesn't automatically run the next command. In such cases, you'll need to press Enter in the command prompt to continue. I haven't figured out the reason for this issue yet, but it seems to only happen during the first training run. The script will proceed with the training process. It starts by uploading the entire AI Toolkit folder, including the dataset we copied earlier, to Modal. During the first run, it will also take about 6 minutes to build the image on Modal. For subsequent runs, Modal uses a cached image mechanism, so this step won't take any additional time. The next step is that the script will automatically create bucketed images to prepare the data for training, and then the training process will begin. Training for around 3,000 steps typically takes about 45 minutes. You can train multiple LoRAs simultaneously, so next, I'll proceed with training the next LoRA. Since the Modal command is running in detached mode, you can safely close the command prompt window and the training will continue normally on the Modal server. Note: only close the command prompt window after all files in the AI Toolkit folder have been fully uploaded to Modal. I've already prepared the images and captions for training the basket LoRa. First, copy the entire folder into the AI Toolkit directory. For the previous dataset, you can delete it since it has already been uploaded to the Modal server. This also prevents re-uploading the old data when training the basket. Of course, it's a good idea to keep a backup of the data in another location on your local machine. Next, I'll modify the config file by updating a few parameters while keeping most of the others unchanged. I will only change the following parameters: name, trigger word, folder path, and steps. Additionally, I'll update the sample prompts to match the new dataset. To compare the images generated by the LoRa with the original training images, I'll use some prompts directly from the dataset. Finally, rerun the script. You can save your modal token in a separate file for easy reuse without needing to generate a new one each time. Since this is the second run, the script will execute faster as it doesn't need to clone the repository or install dependencies again. It will detect that the Flux model directory is already present, skip the download, and reuse the image built during the first run. The training process will then begin. As you can see, we now have two containers running simultaneously on the H100 GPU. You can check the logs for each container to monitor their progress. If each LoRa is trained with a total of about 3,000 steps and runs on an H100 GPU, it will normally cost about $5 for each LoRa. With $30 free, you can train about 5 or 6 LoRa at the same time. The first LoRa is nearly finished training, with a total runtime of around 45 minutes, while the second LoRa has just started. Once the entire AI Toolkit folder is uploaded to the Modal server, you can close the command prompt window. Sample folder will contain images generated during training. You can either view it directly on Modal or download to your local machine. The first LoRa has finished training. I'll go back to the repo to retrieve the command for downloading the results to my local machine. First, I'll download the sample images to check which step produced the best quality results. Once I've identified the optimal step, I'll download the corresponding LoRa file from that step. The style I'm training is a combination of realism and giant-sized characters illustrated in a flat style with stylized limbs. From step 1000 onwards, the LoRa was able to start generating this style. However, the most clearly defined results, in my opinion, are at step 3000. Therefore, I'll download the LoRa file from step 3000. You can name the downloaded file like this, or if you want to download the entire folder containing all the LoRas from different steps and the samples, you just need to point to that folder. The second LoRa is still in the training process, so now I'll talk about how to generate captions automatically to prepare datasets for LoRa training. There are many methods to create captions in natural language style, and since Flux seems to favor captions written this way, you can use models like Florence, Joy Caption. However, in this example, I'll use Google's Gemini API via ComfyUI. It's also free and allows you to create captions based on instructions, enabling you to structure captions the way you want. I created a custom node specifically to use the Gemini API because the existing nodes I found in ComfyUI were outdated. They either didn't support the latest Gemini model or weren't suitable for my needs. To install this node, simply clone the repository into the custom nodes folder in your ComfyUI directory and restart ComfyUI. Let's try using this node. I use the load image batch node to load images from a folder and the save text node to save the captions. set the mode to incremental image, ensure file name text extension is set to false, and convert file name to input. I select Gemini 2.0 Flash. I'll regenerate captions for these images. Copy the folder path and paste it into the respective fields. Then, add the Show Text node to preview the captions. Go to Google AI Studio to get the API key, create a new one if you don't already have it, then copy and paste the key into Comfy UI. You can also save the API key into the config file like this. To test the captions, I start with one image without adjusting the system prompt. As you can see, the results aren't as expected. Next, I'll create a system prompt to customize the output. I'll enter the system prompt in this section to guide Gemini in generating captions as per our requirements. I referred to 2 detailed posts on Civit AI about creating captions for images. You can check the links in the comments for more information. When generating captions for training objects, the general rule is to describe everything except what you want the model to learn. For example, in this illustration, we aim to caption everything in the image except the woven basket. I use a trigger word to name the basket. Captioning is like solving for X in math. You know what a woven basket is, but the AI doesn't. To teach the AI, you must define X by also clarifying what X is not. I avoid describing the basket's specific features, such as its shape, material, color, or number of compartments, as these are the characteristics I want the model to learn. To ensure the captions follow this principle for training the basket object, my system prompt will look like this. I'll first test it on one image. Okay, the output caption now follows the desired structure. Since there are 18 images that need captions, I'll set the batch count to 18 and then press Q. Here are the results. If you find this video helpful, please like and subscribe to stay updated with more tips and tutorials. If your dataset contains a large number of images requiring captions, errors may occur during processing due to Google Gemini's limitation of 15 requests per minute. In such cases, you can add a sleep node in Comfy UI to slow down the requests to meet this limit. The second LoRa has finished training, so I'll download the samples folder to evaluate at which step the LoRa produces the best quality. The first 3 images here are sample images without the LoRa. As the steps progress, you can see the model gradually learning the characteristics of the basket. From the results, starting at step 1000, the LoRa appears to have formed the basket's shape, but it's not very clear. By comparison, at step 2000, the basket's shape is more defined, and the overall quality is better. However, even at step 2000, the LoRa hasn't perfectly captured the number of compartments from the original image. Keep in mind that whether the generated images match the desired shape also depends on factors like the prompt adjustments and the strength of the LoRa during inference. To improve this, I'll continue training the LoRa, Continuing an existing LoRa training is straightforward. Change the total number of steps you want to train in the config file, run the script again. Additionally, you can train with a new dataset. For this example, I'll try modifying the captions to improve results and see if this works. I used ChatGPT to create a system prompt for Gemini, referencing the two detailed posts on Civit AI to guide ChatGPT. After refining the system prompt, here's the final prompt I'll use. I tested the new system prompt on a single image and the generated caption met my expectations. Next, I'll recreate captions for all images in the folder. All captions have been recreated. Next, I will edit the config file. I'll add 2,000 more steps to the total step count in the config file, making it 4,000 in total. And update the sample prompt as well. Replace the old dataset folder in the AI Toolkit directory with the new dataset containing updated captions. Run the script again and monitor the logs on Modal. The script automatically detects that the LoRa was previously trained. Since I set the total steps to 4,000, it resumes training from step 2,000, adding 2,000 more steps. As long as you haven't deleted any files from the previous training output, you can resume training simply by updating the total steps in the config file and rerunning the script. Finally, I'll close the command window and check the training results after the process completes. After about 32 minutes, the training process for this LoRa was completed. Next, I will download the samples first to check how the generated images look. Since the samples at step 2000 will also be recreated, we need to use the force flag to overwrite the old files. Through the samples on a white background, the differences between the images generated at each step become more evident. After comparing several images, I'll choose LoRa at step 4000 to download. After downloading, I copied the LoRa file into the LoRa's folder in ComfyUI. Next, I will test the LoRa on my local machine. A simple workflow will be set up to perform this, starting with the node sample custom advance. When creating workflows in Comfy, I usually start with the sampler or sampler custom advanced node. I find that this makes it easier for me to connect to other necessary nodes. To create product images of the basket for selling on e-commerce platforms, I prepared a number of prompts. Initially, testing with a single prompt to see how it works. The next step is to run all these prompts using the node text load line from file combined with text multi-line. Let's see some cherry-picking results with this object LoRa. I haven't yet tested it with different strengths of the LoRa and left it at the default value of 1. On average, I was able to select one decent-looking image out of every 3 generated. And here are some results with Style LoRa. For the Style LoRa, I experimented with different strength values, and interestingly, this style is most clearly expressed when the LoRa strength is set to 1.3. To wrap up in this video, we've explored how to train multiple Flux LoRAs simultaneously on an H100 GPU for free. We covered the process of generating captions automatically and structuring them to meet your specific needs. I also show how to resume training a LoRa if the initial results weren't up to your expectations. Additionally, we discussed best practices for crafting captions and broke down the key configuration settings. In the next video, we'll dive into training custom LoRAs for the Hunyuan video model and show you how to create videos using it for free. So, make sure to subscribe so you don't miss it. If you have any suggestions for future topics, I'd love to hear them. Thanks for watching, and I hope you found this video helpful.